Have you ever been working on a math problem and you just hit a wall? Well, today we are tackling exactly those kinds of tricky algebraic equations. We're going to build your ultimate toolkit for solving them. So let's get right into it.
We've all been there, right? You're cruising through your work, feeling pretty good, and then bam, you hit an equation that just looks like a tangled mess. It doesn't follow the simple rules you've learned, and it's so easy to just feel completely stuck.
Yeah, you might see an equation with a square root or maybe one with a weird fractional power. At first glance, they can definitely look pretty intimidating, no doubt about it.
But here's the good news. That's exactly what we're here to do. Think of this as heading to the workshop to build a mental toolkit. By the end of this, you're going to have 4 specific, powerful tools that'll help you crack these problems with way more confidence.
All right, first up in our toolkit, we're going to learn how to tame those fractional exponents. Let's dive into how you handle equations where the power isn't some nice, neat whole number.
So what even is a rational exponent? It sounds complicated, but it's really not. It's just a super efficient way of writing 2 instructions at once. The number on top, the numerator, tells you the power, and the number on the bottom, the denominator, tells you the root. It's a power and a root all in one neat little package.
Okay, so the game plan here is surprisingly elegant. First, you get the tricky part all by itself. But the real secret sauce, the magic move, is step 2. You raise both sides of the equation to the reciprocal of that exponent. You just flip the fraction upside down. That one move is what cancels out the fraction and unlocks the variable. It's a really neat trick.
And check this out in action. See how raising both sides to the power of 4/5 just poof, clears away the exponents on the x? It completely transforms the problem into a much simpler calculation.
All right, tool number 2. Now that we've handled those fractions, let's get to the root of the problem. Sorry, I had to. We're talking about radical equations, the ones with those square root symbols.
The definition here is really simple. If you ever spot a variable, an x or a y, hiding out under a square root symbol, well, you're officially dealing with a radical equation. Are you starting to see a pattern here? Just like before, our strategy is to isolate the part that's causing all the trouble, in this case, the radical, and then we hit it with its inverse operation. For a square root, that means squaring both sides.
And here's that strategy playing out. By squaring both sides, the radical on the left just vanishes, and what are we left with? A much friendlier quadratic equation. And we already know exactly how to solve those.
But, and this is a big but, this tool comes with a very important warning label. The process of squaring both sides can sometimes create answers that look right, but actually aren't. They have a special name, extraneous solutions. And this is why that final step is not just a suggestion, it is absolutely essential. You have to take your final answers and plug them back into the original equation to make sure they actually work. It's the only way to catch those sneaky, fake solutions.
All right, tool number 3 is ready to go. This one's for tackling equations that use those vertical bars. And as we know, those bars mean absolute value, which is really all about a number's distance from 0. So the core idea here is simple, but it's really powerful. If the absolute value of some expression is, say, 8, it means that the stuff inside the bars could have been positive 8, or it could have been negative 8, right? Both of those are 8 units away from 0 on a number line. This means we always have 2 possibilities to check out. So the big takeaway here is that one absolute value equation isn't really just one equation. As soon as you get that absolute value part by itself, you're going to split it into 2 separate, much simpler equations that you can solve.
And this shows that split perfectly. A single absolute value problem branches out into 2 distinct paths. We just solve each one of those down the line to find all the possible values for x.
Now for our final tool, and honestly, I like to call this one the master key, because it's this really clever technique that can transform an equation that looks incredibly complicated into something you already know how to handle.
Okay, I want you to look really closely here. Do you see the pattern? In the equation on the right, the exponent of the first term is 4, and the exponent of the middle term is 2. One is exactly double the other. That structure, it's identical to the structure of a standard quadratic equation. And the magic trick we use here is substitution. We temporarily swap out the more complex part, in this case the x squared, with a simple new variable. We'll call it u. This lets us rewrite the entire equation as a basic quadratic with u, which is way easier to solve. It's all about making the problem easier to look at.
And this is the aha moment. It's a perfect example of the power of that simple substitution. That intimidating fourth-degree equation instantly becomes a simple quadratic in terms of u. And once we solve for u, we just substitute back and solve for the original x. It is an incredibly powerful technique.
And there you have it, 4 powerful tools for your algebra toolkit. So let's do a super quick recap. Think of it as a reference guide for when you run into these problems out in the wild.
This is your cheat sheet. When you see a fractional exponent, think reciprocal. See a radical? Think isolate and square. See absolute value bars? Think split it into 2 cases, positive and negative. And if you see that special pattern where one exponent is double the other, you know it's time for a substitution.
So, remember, these aren't just abstract problems in a textbook. These exact skills can be used for things like calculating the period of a pendulum, or even figuring out the body surface area of a person. These tools unlock the ability to model the world all around us. So the real question is, what will you figure out next?